So I've got clean UVs. It's all within the 0 to 1 UV space. And if we go into Maya, and if I select one face, let's say a face right here, I can go to nHair. I'm going to open up this menu set, and I can go to, and rather than creating a curve and then making it dynamic, I can select a face on a plane like this and create a hair. So a few things I want to change here. I don't need paint effects. I'll just choose NURBS curves. And then here I just want to create a single hair at the selected surface that I have already selected, the one face. You can cover the whole thing in hair by choosing a grid, and it will divide the UVs by 8 here, so it will, and then it can fill in with passive hairs. So when you create a hair, it creates a follicle that's attached to the surface, and it creates an output hair, a hair system that controls the quality of the hair, and then a nucleus node. So that one that's attached to the follicle is dynamic, so it will react to forces and all that sort of stuff. But if you need to cover a big area, if you cover it all with dynamic hair, it will become too heavy to simulate. So passive fill puts in a certain number of dynamic hairs and then fills the gaps in between with passive hairs that just follow the dynamic hairs around them. So if you had to create like a field of like flagella or cilia or something like that, you could use that to be more efficient. But we're just creating a single hair on this one face that we have selected. We want it to be dynamic rather than a static hair. So a static hair is the passive kind. Points per hair, so just how many CVs it has, and then the length that it has here. All this stuff doesn't matter. In this case, all we want is the follicle. And so place hairs into hair system shape 1. We already have a hair system shape, so we can just use the same one, or we can force it to create a new one for us. So I'll just create a hair. And I don't see anything, but let's see. We just play back. Okay, let's try that again. I'm going to try with a new hair system because I hid that other hair system. Oh yeah, it's because I had hidden the other hair system. So you can see it's created just a single hair here. And it's not going to do anything, or it shouldn't. But anyway, all we need is this follicle here that's on the ground. So if we look in the outliner, we should see a new hair system shape, new follicles, new output curves. We don't need any of those output curves. We just need this follicle. So let's look at what is in this follicle here. So in the follicle, it has all this stuff that we saw before for the point lock, for the curve that's attached to it, all this kind of stuff with the stiffness of the hair. But what's important here is the parameter u and parameter v. This is where it's located on this plane. So the uv coordinates of where it was first attached. And it's going to stay stuck to that position, but it can also be animated. So if you need something locked to a surface but that can slide over the surface, you can use a follicle for that. So for example, I can set a key here on parameter u, and then over a number of frames. So this is a value between 0 and 1. So if you go past 1, it's going to jump back to the other side of the plane and keep going. So if I just change this to 0.8, so now you can, it's hard to see, but it's right here. And if I play back my animation, you can see it move from that position to that position. So this acts just like a rivet. It's kind of a weird workaround, but it's something that's used in Maya all the time. And if I select these vertices, of the plane and move them, then the follicle should move along with it. And there it is. Hard to see, but there it is, my little follicle. So instead of using a rivet, you can put follicles where you need to lock things down onto a plane. Just delete everything except for the follicle itself. So let me just undo out of this. So for example, I've got this follicle here now. Or maybe I undid too much. Oh no, there it is. So I'm just going to create something like a sphere. And if I select the follicle and then constrain the sphere to it, I'll use a parent constraint. But I'm going to turn off maintain offset this time and click apply. It jumps to the position of the follicle. And if I just select this and put the new material on here. And it's constrained to the follicle, and you can see it will follow, right? So it's an indirect method of animating this because you have to animate its U and V position. But it works, and it actually works quite well. So let's say we wanted to lock down the feet of my bacteriophage. I'm just going to put this into reference mode so I can't select this stuff. Oh, there's that hair that I created inadvertently a little while ago. I'm going to delete all that extra stuff. I don't want to accidentally delete the other things I created. So let me create another hair again. I'm going to create one sort of near this foot. So I'll select this face, and I'll do the same thing. I'll go to N hair, create a hair at the selected location, and again I'm going to create a new hair system shape for this. It doesn't really matter ultimately, but I don't want to interfere with the hair system shape that I already have created. So I create that, and you can see it creates a hair with a follicle. I don't need the hair output curves, so it leaves me just with the little follicle here. I think I can probably even delete the hair system shape. I'm not sure. Let's try. I'm just going to delete that. And if I select this plane and move, oh yeah, so it still follows. So you can even delete the hair system. And if I select this follicle, I should be able to, yeah, I can still move it along the UV direction. So now if I, let's say, take this foot controller, and I can constrain it to this follicle. So select the follicle first, then select the foot controller, and if I do a parent constraint here, again I can turn off maintain offset, so it will just pop over there. So it just pops over. Now you can see it tried to match the rotation. So in this case I probably do need maintain offset. So let's try that again. Constrain parent. So I'm going to turn on maintain offset, but I'm going to move it into position roughly first. Click apply. So now if I were to do something like deform this surface, and I'll put a simple deformer on it, like a nonlinear sine wave. Sine wave always points up in the y-axis, so you have to always rotate it down into position. And rotate it again. And then I'll just put a little expression in offset, just to say offset equals time. So it'll just run through, it'll just animate that thing. And so let's look at what it does with the foot here. Maybe my amplitude is a little high. Let's turn that down a bit. Oh, I don't know what just happened to my head there. Maybe I shouldn't have deleted that hair system shape. That's weird. So just ignore that part. Ignore it. Just pay attention to my other success. So, but you can see that once, if you set up a rig and it's working properly, and you want it to interact with an environment, rather than trying to animate the ground moving, then match that animation by moving the legs yourself, you have to use constraints and things like that. But you can see the sort of very defined step-by-step process to get everything working properly. So why did that happen? What is making that fall? That is bizarre. I must have deleted something I shouldn't have deleted. Let me just try that again. Since that hair system is moving down, if I turn off.
Like is there gravity or something?
Yeah, there's some gravity going on here, but it's still going down. I think it must have happened when I was creating those hair system shapes. I must have deleted something I shouldn't have, because it looks like that looks like gravity more than anything else. So I don't think I have keys on anything else here. If I just look at the scene summary, there are no keys on anything. So I must have just messed something up. And this happens a lot in a lot of animations. You need to lock something to a surface. So using a follicle on the surface is a low processing intensive. It doesn't have to calculate much. It's just locking it to the UV value location on that. So the trick is that you have to have the UVs laid out for the surface, but most of the time it's just something simple like this. And if you don't have UVs laid out, and it's something you don't need to paint, but you just need clean UVs, you can just select an object and go to UV and do an automatic UV creation. And it will just lay out your UVs properly in the 0 to 1 UV space. It would be an ugly mess if it's any kind of complex model, but at least there'd be no overlapping UVs. So every location on the surface of that model would have a unique UV address. And that's what you need for the follicle. Now, it wouldn't work well if you had to animate that follicle moving, because if UV addresses are cut up in such a way that it gets to 0.5 in U and then it jumps to another part of the surface, it wouldn't work. But if you just have to lock it down to the surface, you can just use an automatic UV creation like this. Okay. So that thing is still, I think that finished, and I'll upload these. That's really all I wanted to show you today. It's just an interesting model that brings in a lot of different things, different types of rigging, thinking about parenting rather than skinning, different types of IK handles, and also setting up a rig that you can easily move around. Now this thing, if I try and move it now, its leg is going to be stuck. Because that's overriding the parenting here. So, yeah. Did you have a question?
Yeah, so right now you only have the skeleton for the legs. How would we end up like skinning that part? Because like, if we were to render it out now, it would only.
Yeah, so it would just work in the same way. Like if I just go in. Yeah, I'm just going to reopen this scene again because things have gone poorly for me. So if I just go back here, let's see if he falls through the floor again. It's probably because I'm just going to go into the graph editor and delete these keys. Actually, no, I'll just should still delete them here. So okay, his head stays in place, so that's good. So if I just go in here, for example, not this view. If I go in this view, I can make one leg. So I can either make sort of a jointed leg. If I just create a curve, so oops, I'm just going to use my snap tools. What's the best way to do this? Yeah, so oops. I'm just putting some extra points in here. So when I need to make a sharp turn with my curve, I need some extra points to do that. So I've got a curve now. And if I just create a NURB circle or something like that, I can select the circle. I'm just turning off my other selection masks. And the curve. Go to surfaces and extrude. So this is not a polygon extrude, this is a NURBS extrude. And so this will make a NURBS object. So I made a big fat leg. So instead of a fat leg, we want a small leg. So I can take that circle that I extruded from and just shrink it down, because we still have construction history turned on for this. And I'm just going to delete this curve, and that will delete the historical connection between them. Turn on my geometry selection. So I have a NURBS object here. I want to turn this into polygons. It's also inside out. So I can convert this to polygons. So let's go to modify. Now you can do this in the extrude process itself just by selecting polygons as the output. But if you forget to do that, you can just select and go to modify, convert NURBS to polygons. I'm going to open up the options for this. And usually you want to convert to quads. So these quad-shaped spans on a NURBS object. It's going to match and then go to control points. And if you tessellate, tessellate means to turn something into triangles. So you're turning it into a piece of polygon geometry. So you got the extruded surface here originally, and the NURBS to poly here. I'm just going to delete the extruded surface. The NURBS to poly is still inside out, so it's a normal problem. Mesh display, reverse normals, and we're good. I'll name this according to whatever leg this is. So this is leg F, so I can call this leg F. Of course I'm going to have to rename these in a minute. Nope, didn't like that. Okay, so now the same old, it already has its pivot point in the middle of the world. So if we just go to Edit, Duplicate Special, still have the same settings in there, so I can duplicate that, I have a leg in each spot. Now this is uninspired modeling here, but you get the idea. And if I delete the history, freeze the transformations, now you can skin to these joints. So in this case, we only want these legs to be skinned to the nearby joints. So we could select the joints we want to use. So not the reverse foot. It's not the reverse foot that we're interested in. It's the forward foot. So I can select that. Shift select the... So I just selected the 3 joints up to the hip of the forward leg. And then the geometry. You can go to skin, bind skin, just like before. Leave this at the standard settings, except we want to bind to selected joints rather than the entire joint hierarchy, because that would include the neck and everything. So now we can bind skin. Let's see if it did anything. And now it's going to follow along. So you can have a single joint system, and you can bind different pieces of geometry to it if you select the joints you want to do. Or you can have, like in the case of a body, a lot of the time you'll have just one entire model in one joint system, and you skin the whole thing, and then you got to go around and paint weights and make sure that, like one common thing that can happen if you're doing a whole body and you skin, when you move the arm up, it pulls part of the side of the body up because it's within the region of influence. So you just have to paint out the weights here till it's black, and so when you move the arm, none of these joints influence the thing here. And you might want to when you move the arm up, the serratus anterior, or rotating the scapula around. So there might be cases where you want to do something like that, but it's mostly about painting weights to get that right. Yeah.
If you've skimmed something, is there a way to like unparent it or like detach it without ruining the rig?
So yeah, without ruining the rig, yes. But if you have rigged something, modeled something, then skinned it, you can go to skin and unbind skin here. But then if you've painted weights and all that stuff, you're going to lose that. Right? So you really, when you do this rigging workflow is pretty directional. Like you want to get your rig working properly with all the controls and everything before you skin and paint weights. You want to make sure everything is working before you go to that next step to paint weights and things like that. Because then if you decide, oh, I need an extra joint in the spine, that's a big problem. Because now you've got another control object and you've got to figure out how it's controlling the vertices around it, things like that. So, Wendy?
If you had so say you constrain the legs onto your surface.
Yeah.
And you're animating it.
Yeah.
Do you want to lift one leg off?
Yeah.
What happens if you just lifted that one off and step back?
So that would be similar to what we had before when we did the picking up the ball and throwing it. Remember?
So you have to animate it coming off of the...
So yeah, you'd have it constrained to that follicle and it's moving around. And then if you put a keyframe on that foot that you wanted to lift up, you would get that pair blend thing again. Remember that?
Yeah.
And then you would keyframe pair blend. So when it's on 1, it's paying attention to the constraint. And when it's on 0, it's paying attention to your keyframes. So if you want it to follow and then lift up, you have to animate that. Do you guys remember that from the baseball thing? So let me just do something like that quickly. So here we've got this leg, and so it's free to move around, right? So I'll just do something simple. I'll just create a cube. So I'm not doing the follicle part here, but I can just constrain this thing to this cube. So imagine the cube is the follicle, right? So you want to select the cube first, and then the part of the rig, because the last thing you select is the thing that is constrained. So constrain, I'll do a parent constraint with maintain offset turned on. So once we've done that, then there's this new node associated with this controller called pcube1wo. This is the constraint, right? Sorry, that's the node. This is its attribute. So now if I move this cube, the foot follows, right? So it's constrained to it. So now if I want that, and let me just do a little animation so we can see. So I'll just key the cube here, 20 frames, go down a little bit, and then we'll go up again, and if I go into the graph editor, so this one is at put this one at the same. And if I just repeat this animation, oops. And we'll just get an animation of that cube moving up and down, and the leg following. Okay? So at some point in this time period, we want to grab this thing and actually move it by hand. So let's say here at frame 196, we set keys on translate. Now all this stuff turns green. That's because it's got a constraint controlling it and a keyframe controlling it. So if you remember, it introduces this pair blend node. So if I just select this again, and you've got this blend parent attribute here. So if I play the animation, it's not following it anymore, right? If I change blend parent back to 1, that means it's following the constraint. So when we get close to here, we can, when it's supposed to lift off, we can set a key here that it's following the constraint, then maybe one frame later turn that off, so now it's following our keyframe. And then we can now animate this thing going like this. So it's following the constraint. Great animation, eh? But that is the benefit of using constraints rather than organizational hierarchy of parenting and children, is that you can keyframe things like the constraint turning on and off, or listening to keyframes, or the constraint. Any other questions? That's that stuff. Nope. Okay, so my homework is to figure out where to put that follicle to get the head to bounce around. And your homework is just to do whatever you want. Just keep working on your shots. So I wouldn't mind if you guys went through and tried to finish setting this up. I think my video's finished. Let me just double check. Oh, a picture of me. Great. What am I doing? Okay, it looks, ooh, 1 gigabyte. It's huge. Oh, this is a picture. Okay, it did not, the first one finished, so I can upload that. looks like. I still have to export the other one.